Hello. Okay, I think absolutely no problem now. And please take care that nobody is on meeting. So it is work towards. Yes, I have to share again. Today we are going to learn about some another integral part of statistics. Actually, basically, statistics is itself a separate branch, even though we used to say that statistics is branch of mathematics. Of course, in terms statistics has so many different sub branches, and broadly statistics has been divided into two parts: descriptive statistics and inferential statistics. So let us continue here. So because of this coronavirus, we all get deported, and from many days, these schools, colleges are closed. Online education has become an unavoidable part of our education system, and let us hope that it is going to close soon. So branches of mathematics. So such vast subjects, so many sub branches, and statistics is one of the sub branch. And here data types, basically categorical means non-numerical and numerical. In categorical, nominal and ordinal. Similarly, in numerical, interval and ratio. I have already gone through this. Now, categorical data represents characteristics. Therefore, it can represent things like person, gender, language. Categorical data can also take numerical values for our convenience, but it has absolutely no meaning as such with respect to numerical, and preference is also not always carrying any importance. Statistics is divided into two categories, that is descriptive statistics and inferential statistics. In descriptive statistics, we have seen different types of data, then different measures of central tendency, measures of dispersion, moments, then skewness, kurtosis, correlation, regression, analysis. So such things are coming under the head descriptive statistics, whereas in inferential statistics, we are having a broader area in the sense that we are going to take care of, understand the meaning of population, sample, and we may talk about entire population, or we may have different populations. We may compare different populations, and accordingly, what is meant by statistic, different probability distribution, and so on. The testing of hypothesis is a very important part of under the inferential statistics. So this is also very much inferential statistic is very much useful, and that is very much in concern with all the researchers in any area. So descriptive statistics is with collection of data, presentation in various forms such as tables, graphs, primary thing, diagrams, further finding averages, measures, the descriptive data, like that. Whereas your inferential statistics These fit techniques used for the analysis of data, making estimates and drawing conclusions from limited information, obtained through sampling and testing the reliability of the estimates. Okay, so we will be coming through the examples. Let us try to understand what is meant by a population. Population. So I think just okay. I think I am properly audible. Am I audible? Please tell.
Yes, sir.
Yes, sir.
Yeah.
Okay, okay. So what is meant by population? Actually, my headphone is not working, so I'll have to pick this mobile very close to me. Population for a common person. When I say that population of Baramati is around 5 lakh, that means that 5 lakh people are living in Baramati. That is a simple meaning. People means only human beings, adults, kids, and so on, as such. But in statistics, the word population has something different meaning. Population is nothing but an aggregate of facts bearing identical properties. An aggregate of facts or entities. Our entities can be uh, humans, other living things, or even non-living things, but bearing identical properties. So when we say horses, a population of horses, so we can understand that no other animal will be included, even man will not be included in that population. So that is very much obvious. So this is the definition of population. So generally it is assumed that there are thousands, even more than that number of observations. On some occasions there are infinite number of objects in that population under study. And what if you want to make some statement about the population, the best way is to study each and every entity in that population neatly with respect to the parameter of our interest. So accordingly you can define an attribute or a variable of interest, note value of that variable for every entity in that population, and then come with a result, and that is going to be the most reliable and accurate conclusion you will be making about the entire population. But practically it is not possible. The reason is that when we want to study the entire population, it is time consuming, it is labor consuming, it is money consuming, it is laborious also, and that's why the concept of sample has been introduced. So you already know you have heard the word population. So I have elaborated. I have been successfully to explain you the meaning of population, and now you know meaning of sample. So what is sample? So you have been using or heard this word sample in on different occasions in regard to different meanings. कधी कधी म्हणतो काय पण सॅम्पल आहे हा, असं पण म्हणतो. कधी कधी एक कधी वेगवेगळे सपोज देर इज अ वन stall in that sample is also available. That is not the meaning. So sample is something different. That is a sub part of the population, or you can say it is subset of population. A simple way, a proper representative uh, and a subset of a population under study. Population under study. So yes, it is a science, it is an art to make conclusion about the entire population, not just studying it completely, but just studying small part of it. And sampling theory is another very big and vast topic, which is again a sub branch of statistics. So we are not going to go into such many details. And again, there are so many different sampling techniques, random sampling, lottery system, stratified. So many different sampling methods are there, and each has some merits, demerits, efficiencies. So many things are there. But let us try to understand why and where this technique is going to be used. So I want to say that yes, definitely you can give me some examples wherein sampling technique is used to make conclusion about the entire population. Suppose whenever you are sick from many days, then doctor suggests us to give a blood sample. Then only some part of blood is taken from our body, and from that, whatever the conclusions in the pathology lab are drawn, that is based on for the entire body in our population. So that means here, whatever the few drops you have been taken, this is one example. Otherwise, you must have known your blood group. Maybe O positive, something like that, B positive. So if you remember, only few drops must have been taken before going for the test. Yes. So whatever the few drops have been taken, that is nothing but a sample, whereas the corresponding population is entire blood in the body. So it is not absolutely essential to take study the entire population. Only some part is studied, and definitely we say that if blood group is O positive, that means definitely uh, entire blood in our body has O positive. Yes, so this is 100% accuracy. This is a very nice example of population and sample. Then um, when I used to be very small, so having cookers used to be a luxury. So most of the people did not have even cookers, and the way of cooking rice was really orthodox. Means in a pot, then they used to burn, put some rice, water, salt, and after that they used to cover that pot with some another plate. And after that, after half an hour or something, only 2-3 um, 2 ते 3 कण असे हातामध्ये घ्यायचे, आणि ते असं हाताने प्रेस करून पाहायचं, आणि थोडं नरम वाटलं तर so that means that it is fine. Otherwise, again they are trying for another 10 to 15 minutes. So that used to be the way of cooking. So it was not as easy as nowadays. तर अशा पद्धतीने तेव्हाच शीतावरून भाताची परीक्षा अशी एक म्हण तयार झाली होती. बऱ्याच जणांना माहिती असेल किंवा नसेल माहित नाही मला. बऱ्याचशा म्हणी माहिती आहेत मराठी मीडियमला असल्यामुळे. So that is also very nice example. Only 2-3 grains of rice, that is nothing but sample, whereas the all the grains in the pot is nothing but the population. So we are making conclusion about the entire population. Again, in market ad, when we are going for purchase of wheat uh, for the entire year, then there are so many shops, and when we are entering inside a shop, in inside a particular shop, there are so many sacks kept of different varieties. So uh, again, wheat has different varieties, and in a sack there is some particular variety of wheat. So that is one population. Besides that, there is another sack, that is another population. So many populations are there, and after that, what we are doing, from every population we are taking some part. So we are choosing one sample, we are comparing the samples, and from that we are coming to the conclusion whether yes, this population is better than that, something like that. So this is the theory of sample and population, and it is very much useful in all parts of our life. It is impractical to survey each member of the population and allows for inference about the characteristic of population. Samples can be helpful representative of the entire population, like this. So as such, I have to drop something here. Okay. Let me see what you. Okay, parameter and statistics. This is another thing. See, already now here I will have to. What is meant by parameter? So already I have elaborated the meaning of population and sample. Now, suppose there is only one population. Suppose there is a population of all the students of VPKBIT, and the population size is generally denoted by capital N. Suppose it is 1,800. And I want to talk about what is the IQ, intelligence quotient, of the mean IQ of this population. Generally, mean population mean is denoted by mu. So if I want to know exact value of mu, then I will have to test the IQ level of each and every student in this population. But I am going to avoid that. Then what shall I do? Instead of going studying all 1,800, I'll be considering around 150 to 200. So that will be our sample size. But if I'm going to pick most of the students from computer department, then it is quite possible that I will be overestimating the population, in the sense that is currently the merit of computer people is higher. So that is really not justifiable. So what I'll do, from every class, ACTB, if he is not still there, but from ACTB and from our branches, I will be taking appropriately proportionate number of students, so that the sample size will be, suppose, small n equal to 200, and then I'm going to note down the IQ of these 200 students by our standard method, and then I can find sample mean. Sample mean is generally denoted by x bar. Okay, and then I will assume that whatever the sample I have taken is proper representative of the population, and under that assumption, I will say that, suppose my uh, IQ of the sample is coming as 71, then I will dare to say that the mean IQ of the entire population, which consists of capital N equal to 1,800 students, is also approximately equal to 71. This is going to be the thing. So here in this parameter population mean mu. So parameter is in regard to the characteristic in regard to the population is called as parameter, whereas the corresponding uh, function of the sample values in relation to the sample is called as a statistic. So here it is quite possible that if I'm talking about population mean, then parameter will be mu. Mu will be the parameter of, whereas x bar will be the sample mean, sample mean will be called as a statistic. So this is the meaning. So a parameter is a characteristics of a population, whereas a statistic is a characteristic of a sample. Because a parameter is found out only when you know data about everyone in the population. It is fixed. Yes, parameter. It is a. It is fixed. Absolutely, as long as we are concentrated on a particular population, value of mu is fixed. But for the same population, on different occasions, we may take different samples, and accordingly, every time we may have different sample means. So X bar may change. Okay. In contrast, a statistic that describes the same population can vary. This is because you can take different samples from the same population and get different results. So a parameter is obviously more reliable than a statistic. Still, when a population is so large that nobody has the time or the resources to ask everyone, a statistic will provide enough information to draw the conclusions. Yes, we are tolerating a reasonable risk, and yes, we can minimize our effort and we study only the sample, and from the sample itself we are making conclusion about the entire population. This is the power of the sampling theory. So here example, this students studying in a college, IQ of these students exists. We are generally unaware about the same. Yes, that exists. That population mean, population variance, these parameter quantities always exist, but we are generally unaware of this. Suppose we can find the IQ of each of 2000 students and add these IQs and divide by total, that will be population mean, which is denoted by mu. Yes, it exists, but we do not know. If you want to know it correctly, then what you get IQ of all these 2000 students, then find its arithmetic mean, that will be the exact value of mu. The formula, this is the formula I just told. But we can understand that getting IQ of each of these students is not so easy. So we draw a sample from this population of appropriate size. Let there be small n equal to 200 students selected from the population in appropriate proportionally from all the streams. Now it is comparatively easy to get the IQs of the students in the sample. If we add the IQs of all these 200 students in the sample and divide, then that will be called as sample mean, which is denoted by X bar. Remember, X bar is sample. Either, there should be small n here. So please, yeah, there should be small n number of observations here. So this is the basic difference. Mu means population quantity parameter, whereas x bar is statistic, and from that, if s is attached, many statistics are there, then it becomes statistics. So that is the origin of this word statistics. Definitely you understood that. So how we draw the sample is very important, because the reliability of the results which we are going to make about the entire population are going to depend from the sample. Okay. Just give me a few seconds. Oh, okay, sorry. So I'm back. Let us continue with. Now, the population mean mu is parameter, whereas sample mean is a statistic. If the sample mean turns out to be 72, yes, we take some risk and we dare to say that the average IQ of the students of the college is around, means the mean of the population is also 72. As we have discussed about the mean, we can do the same thing in case of variance, standard deviation, and some other functions also. Okay. Now we want to know about this entire population here. So this is random selection and sample mean. We are making inference about the entire population. One example, diastolic blood pressure. So there are so many people in a particular locality. Suppose their mean blood pressure is 78 mm Hg in appropriate unit, but it is unknown. Now we may draw samples. Again, what should be the size of sample? That is another aspect. So accordingly, you can have samples on different occasions of different sizes, and accordingly, you every time you will be getting a different mean of the samples. But believe me, there is one theory that if all possible samples are there, then if you take
the means of all the samples, then that is going to be exactly equal to the mean of the population. Now, coming to the point, hypothesis. Hypothesis means a statement regarding a population under study. Statement, simple statement. So the statement may be like this. Suppose we have a population of all the students of PPKBIT. We may have statement. The average IQ of for this population is 72, or it is less than 80. It is greater than 80. It is not equal to 80. These are the different types of hypotheses. Again, we may compare two different populations simultaneously. Means, suppose population 1 consists of all the students of PPKBIT, whereas population 2 consists of all the students of Madgaon Engineering College. And in that case, my attribute of interest is IQ. So mu1 will be the average IQ of the students of population 1, whereas mu2 will be the average IQ of students of population 2, like that. So my hypothesis may be mu1 equal to mu2, means the average IQ of both the populations is the same. Or my hypothesis may be mu1 greater than mu2, or mu1 less than mu2, or mu1 not equal to mu2, like that. So this is all about hypothesis. Hypothesis is usually considered as the principal instrument in research. Yes, we have to first fix what we have to do, and accordingly we have to do further analysis. A hypothesis is mere assumption or some supposition regarding a population or population under study to be proved or disproved. Yes, so automatically after performing all the necessary steps, we will be coming to the conclusion whether whatever the assumption we have made initially is either to be accepted or rejected. But first, we must have something in our mind. So that is presented in the form of a hypothesis. Quite often, a research hypothesis is a predictive statement capable of being tested by scientific methods that relates an independent variable to some dependent variable. For example, students who receive counseling will show a greater increase in creativity than students not receiving counseling. Yes, very much understandable that. So suppose in our college there is TNP cell. If TNP cell is absolutely not active, it is not conducting any training activities, and the students are directly appearing for the campus interviews, then whatever their performance, number of placement, this is one aspect. And suppose uh, our TNP cell is very much active and they are giving all the possible training, and after that our students are appearing for the different campus drives, and then definitely if there is considerable improvement, means the number of placements are really increasing drastically, then definitely we say that the quality of the TNP cell is going to be very much effective towards the improvement of the placement. Yes, so this happens. Similarly, another example, the automobile A is performing as well as automobile B, means there are two company products, those are equally good, like that. Then next, there are two types of hypothesis, null or simple hypothesis. So it is a simple statement. Generally it is denoted by H naught or HA. H naught, null hypothesis, this is H naught, or H. like that. And generally it is mu is equal to 72, mu1 equal to mu2, something like that. Equal to is there. And it is the simple ones. That's why. Otherwise, another is alternative or compositive hypothesis, which is complementary or in negation to the null hypothesis, and that is called as alternative or composite hypothesis, which is denoted by H1. This is denoted by H1. So H0 and H1. So we'll be making use of this. If we are to compare method A with method B about its superiority, here the assumption that both methods are equally good is the null hypothesis. As against this, the alternative hypothesis can be that both methods are not equally good, or method A is superior to method B, or method B is superior to method A. So complementary of null hypothesis is called as alternative hypothesis. Alternative hypothesis is usually one which one wishes to prove under the assumption that null hypothesis is true, and null hypothesis is the one thus a null hypothesis is one wishes to disprove. Thus, a null hypothesis represents the hypothesis we are trying to reject, and the alternative hypothesis represents all other possibilities, and we are testing for possible rejection. Suppose we want to test whether the IQ of the students studying in a college is 72 or not, then the population is obviously all the students of that college, and the variable of interest attribute is IQ. And in this case, the null hypothesis will be H0 mu equal to 72. And the alternative hypothesis can be, there are three possibilities, but here only one possibility for null hypothesis, mu equal to 72. And again that first possibility is that mu H1 mu not equal to 72. Second possibility, H1 mu greater than 72. And third possibility, H1 mu less than 72. Yes. And accordingly, so we'll be uh, seeing here one or two formulae, and then we're going to stop. Since our sample usually only contains a subset of the data in the population, we cannot be certain as to whether the null hypothesis is true or not. We can merely gather information via statistical tests to determine whether it is likely or not. Often in an experiment, we are testing the validity of the alternative hypothesis by testing whether to reject the null hypothesis. When performing such tests, there is some chance that we will reach the wrong conclusion. There are two types of errors. So this is a very important thing. And in relation to that, see, there are two types of errors. I will try to explain to the best. And after this session also, in coming days also, I am going to discuss within 2-3 lectures about this unit. So whatever is enough for today examination, I will be discussing that, and then we'll be having a pause here. Now, this is, we are talking about testing of hypothesis. Means there is some population, we are making some statement, and we are selecting a sample from that population. We study that, apply appropriate formula, and come to the conclusion whether to accept uh, null hypothesis or accept the alternative hypothesis. So whatever the decision, that is purely based on the sample. We are not studying the entire population, so definitely there is going to be some error. There is difference between error and mistake. Mistake is something that can be improved, and we can completely nullify it. We can make mistake to zero level also, but that is not true with error. Error, yes, we can minimize error, but we cannot completely avoid error. We cannot take error to zero level. So it always is going to be there, 2%, 3%, 5%, something like that. But we cannot completely remove it. That is the difference between mistake and error. And here, yes, error will be there because our decision will be on the basis of this sample. So one possibility is that we are conducting that testing hypothesis, and finally we come to the conclusion that we are supporting H0. This is one possibility. This is our decision. And another possibility is we are supporting H1. These are the only two possibilities on the basis of sample. And in fact, otherwise, the possibility is that H0 is true. Means if we would have studied the entire population, then we would have come to know that H0 is perfect. This is one possibility. And second possibility, no, H0 is not perfect. So in fact, there are two ways. H0 is true and H0 is not true. In fact, and on the basis of the sample, we are coming to the conclusion that we are going to support H0 and or we are going to support H1. So the first situation is that in fact H0 is true, and on the basis of sample we are supporting H0. This is correct decision, absolutely correct decision. Another possibility, in fact H0 is true. On the basis of sample, we are not going to support H0. That is incorrect decision. That is called as type 1 error. Third situation is that in fact H0 is not true, means H1 is true, and on the basis of sample we are supporting H0. That is also a wrong decision on the basis of sample. And the fourth case is that in fact H0 is not true, means H1 is true, and on the basis of sample we are rejecting H0, means we are supporting H1. That is also a correct decision. So out of the four situations, suppose there are 100% occasions, so around 88 to 90% occasions will be in correct decision 1 and 4 type, and in the remaining 10 to 12% occasions will be in either type 1 or type 2 error. There are type 1 and type 2, two types of errors. Type 1 error is rejecting H0 when H0 is true. Remember this. Reject H0 when H0 is true. This is type 1 error, and type 2 error is accept H0 when H0 is false. So between these two errors, which error is more serious? We would like to come to conclusion. This is I will be giving there is some false matrix theory in machine learning. So I will be discussing, I will be taking separate lecture on that in regard to machine learning. Type 1 error, H0 is rejected even though it is true. This is called as false positive. Remember, a false positive, H0 is rejected when it is true. And type 2 error, H0 is not rejected even though it is false. This is false negative. So these are two types of error. And the acceptable level of type 1 error is designed by alpha, while the acceptable level of type 2 error is designed by beta. Now, yes, I'm going to come back to with some analysis because I will have to finish. Yes. There is an analogy. So suppose there is one suspected person who is supposed to who has supposed to do some crime. So we have not yet proved that he is really a criminal, but it is suspected that fellow is suspected, and then there is a hearing in the court, so many witnesses, the entire procedure is followed. So what may be the true in that case? If the here H not is true means the person is innocent. The person is innocent. This is one possibility. And the another possibility is the person is really a criminal. But we do not know. We are completely unaware about that. So what is sampling techniques is adopted means some witnesses are going on, maybe real or not. We absolutely do not know. Then so many hearing, all the procedure is followed, and finally the court gives the decision. Acceptation. That means the person uh, is not sentenced, so released. This is my analogy. Huh? And rejectation, that means so the person is not accepted means the person is sentenced. So this is another thing. So here see, one possibility is that the person is innocent and the person is released without any punishment. So this is absolutely acceptable, correct decision. Second situation, the person is innocent and the person is sentenced. So this is really very much unfortunate in regard to the person. The third occasion is the person is criminal and the person is released without any punishment. So this is also a wrong decision. So this is another type of error. And the fourth case is the person is criminal and the person is sentenced. This is absolutely correct decision. So then again here there are two errors, but you can understand which error is more serious. Means which is the error we will see. Again, the theory is that if we try to minimize one type of error, the remaining type of error increases. So we'll try to decrease, keep to the lowest that error which is more serious. Now between these two errors, which error is more serious? So you can guess. If innocent person is being sentenced, this is very serious, then a criminal is released. So the motto of our justice is that जे 100 काय कोणाला सांगता येईल का? 100 अपराधींना सोडलं तरी चालेल, पण एका निरपराध व्यक्तीवर अन्याय व्हायला नको, हे तत्व असतं. सो type 1 error is very much serious than type 2 error. So we try to avoid, and hence it is denoted by alpha, and alpha is generally taken as 5%. 5%. Alpha is equal to 0.05. 5% on some occasions. So this is the thing. Okay. Then there is critical region. Yes, I will explain those things in coming lectures. One tailed, two tailed. I'm giving some glimpses of the same here. Z test in single population. So here also I am going to explain this a little so that you will be having. Yes. So here, it's not, I will have to change the ink color. So it should be white now. Suppose there is a single population, and I want to test that mu is equal to suppose 72. Let us call it mu naught versus H1. The mean of the population is something different than mu naught. So this is null and alternative hypothesis. So what is done? We draw a random sample. Actually, the population consists of capital N number of elements in that, but we are not interested in learning all. So what we do, we select a sample from this sample of size small n. So the observations are x1, x2, like that, xn. Our assumption is that every observation in that population follows normal distribution. So that is our big assumption. And under that assumption, our x bar will also follow. Actually, every xi observation follows normal distribution with parameters mu and variance sigma square. And under that assumption, x bar, the arithmetic mean of the sample, will follow again. So this is summation xi from 1 to n upon n. This will follow a normal distribution with mean mu and variance sigma square upon n. Yes, sir, we can prove it, and we'll prove this next time. So this is the formula, and immediately I have told you the property z equal to x bar minus mu upon sigma upon root n. This will follow standard normal distribution. And we are assuming that H naught is 2. So under H naught, this z equal to x bar minus mu naught upon. So instead of mu, there is mu naught upon sigma upon root n. That root n can be written here. So this follows standard normal distribution. So this is the thing. And then we have to find the calculated value, compare it with the table value. And this is normal 0, 1 distribution, z-axis versus z-axis. And as alpha, level of significance is 5%, 5%, or that is 0.05. So what is to be done? So the value of z should be very close to 0. If it is going 2 away from 0, then we are not going to support H naught. We'll be going in favor of H1. So this is alpha by 2, means 0.025. This area is 0.025. And in normal, I will tell you that it is 1.96, and here minus 1.96. If the calculated value lies from minus 1.96 to plus 1.96, then we are going to support H naught. So this is acceptance region. Acceptance region. Okay. And this is called as, remaining part is called as critical region. Means if our Z calculated value is less than minus 1.96 or greater than plus 1.96, then we are not going to support H naught. We are going to favor alternative hypothesis H1. This is called as testing procedure. So remember the formula in your exam maybe. Here for single populationचा formula असा असणार Z चा x bar minus mu naught upon sigma upon root n. So this follows normal 0, 1. So this is one thing. And again, we may have two different populations. So mu1 equal to mu2 versus h1 mu1 not equal to mu2. असं जर असलं ना, मग तिथं z चा फॉर्म्युला असणार आहे x bar minus y bar upon square root of sigma 1 square upon n1 plus sigma 2 square upon n2. This follows standard normal distribution. So the first formula is for single population mean, and the second formula is for two population mean. So this is, so we can understand it, we can derive it also, absolutely no problem. This is what I wanted to tell. And after exactly 5 minutes, I am going to stop here. Again, p-value, this is another way of coming to the conclusion. Without p-value also we can come to the conclusion. So I think we'll have to Oh, stop now, so that you'll be getting sufficient time to work on. I'll be just taking screenshot now. Screenshot of your attendance. That will be enough. Just yes, I have taken attendance for screenshots. So